So learn how to compute the correlation coefficient, which is also called R, and also the properties of R. And so what is a scatter plot? A scatter plot is a graph of points on the horizontal axis and then the vertical axis. It helps us to be able to see the picture between two variables. So typically when we have a scatter plot, we have what we call the explanatory or the predictor variable, and we denote that by X. And then the response variable by Y. So for example, if I want to predict your scores or your exam scores based on the number of hours you study, so I am trying to predict your scores. So that means Y is your scores, and that is the what? The response variable. What am I using to predict your scores? I'm using the number of hours you dedicate to study. So then X is the number of hours. Number of hours you study. And so this X here is the explanatory or the predictor variable. So whatever you are trying to predict becomes your response variable or the dependent variable. And what you are using to predict is your explanatory or the independent variable. So for example, if you want to predict the height of people based on their weight, you are trying to predict their height. And so their height becomes the response variable. Does that make sense? You are using the weight to predict that. So the weight becomes the explanatory variable or the predictor. Is that okay? So it's very important that in every problem, you are able to identify the response variable and then the predictor variables. Is that okay? Good. So this is how a scatter plot looks like. So this is the horizontal axis, and then this is the vertical axis. Is that okay? And then each point here has what? X value and then Y. Is that okay? If you want to see the X value, you trace the point to the X. If you want to see the Y value, you trace it to the Y. Is that okay? So the scatter plot, it's a what? It's a graph of what? Points. Is that okay? Or dots. Any questions so far? It's very important that you understand the intuition behind this, because for scatter plot graphs, StatCrunch can do them for you. But how are you going to make meaning of that? How are you going to describe that? That is what you need to understand. And so to describe scatter plot, we are going to rely or discuss this main point. So first, we are going to talk about the direction, and then we'll move to the form, and then the strength, and then also outliers. You already know what outliers are. Is that okay? So for you to be able to see an outlier in the scatter plot, you see that it's far from the rest of the data point. It doesn't fit the pattern. Is that okay? Good. So now let's describe the direction. So for the direction, we are going to have the direction is either going to be positive or negative. Is that okay? So what does a positive mean? Positive means that if you are looking at the positive relationship, it means that they move in the same direction. For example, this thing here is positive because you can see as the value of X is increasing, the value of Y is also increasing. Look at X is 8, look at what you got here. X is 10, you see. So you see as X is increasing, Y is also what? Increasing. Does that make sense? So for positive, it means that what? They move in the same direction. Does that make sense? As X increases, Y also increases. What it also means is that if the number of study hours increases, we expect that your score should also what? Increase. Is that okay? So it means that they have a what? A positive direction. And for you to be able to identify that, you can see that it goes this way. And then for negative, it means that their relationship is inverse. What it means is that if one goes up, the other one what comes down. Does that make sense? And so when you look at this scatter plot here, look at x. When x is 8, you see the y value is what? Small. Is that okay? As x is increasing, the y values are what? Dropping. Can you see that? When x is small, the y values are what? High. So it's very important for you to be able to tell the direction. So whenever you see a scatter plot, you should be able to tell if it is positive or negative. Is that okay? That is the first. The other thing we also want to talk about is the form. So, for example, for the form, we have straight, curved, or others. So, for the form, when you look at this scatter plot here, you can be able to draw a straight line here. Is that okay? And so then you can see that the form is straight. Does that make sense? When you look at this one here, it looks like this. So you see the form is what? Curved. So it's very important that you are able to describe. So now we've learned about the direction and also the form. The other thing we want to talk about, it is the strength. The strength, it could be very strong, it could be strong, it could be moderate, and it could be weak. So for example, when you look at this one here, one thing I would always say that for you to be able to describe the strength, try to draw this. For example, when I look at this one here, you see this thing that I have drew here. If it is small, if the width here is very small, it means it's either strong or very strong. Does that make sense? Now look at this one here. You see it's a bit bigger than this one. Is that okay? Then when it happens that way, it is moderate. Does that make sense? And then when you have something like a box or a circle, it is weak. So anytime you're asked to describe the strength, try to do this. Does that make sense? It could also be if it's very strong, you see, the line will be what? This would be what? The weight will be very small. Is that okay? So that is how to describe the strength. So anytime you're asked to describe the strength, you should be able to what? Do a good job. The other thing we already know what outliers are. So now we are able to talk about the form, the strength, the direction. So outliers, for example, in this graph, we don't have outliers, but if you have outliers, an outlier could be here. Is that okay? They are far from the rest of the data points. So you should be able to identify that. The other thing we want to talk about is what we call the correlation coefficient, or sometimes they call it correlation. So what this does is that this is like a number. Is that okay? What it helps us to do is that it helps us to know the direction and then the strength. Is that okay? So sometimes you won't have graphs, but you just have R. You should be able to know the direction and then the strength. And then this is the mathematical formula for computing R. But then we are not going to do that now because StatCrunch can do that for us. But StatCrunch will not interpret for you. So you should be able to what? Interpret. That is what we are about to do. And before we compute R, you need to make sure that R passes these three assumptions. One, we can't compute R for qualitative variables. Is that okay? Or categorical variables. We can only compute R for quantitative variables. Is that okay? And then we can only compute R for situations whereby the relationship is what? Is straight. We cannot compute R for this. This is curved. Is that okay? But we can compute R for this. Does that make sense? And then we don't want to have outliers because when there are outliers, it has a great impact on the correlation coefficient. Does that make sense? Good. What are the properties of R? One thing you have to have in mind is that the sign of R tells you the direction. For example, If you have R equals 0.5, what is the sign here? Do you all agree with that? The sign is what? Positive, right? So if the sign is positive, it tells us that what? It gives us the what? The direction. It means the direction is what? Positive. Is that okay? So if you have R to be negative 0.5, what is the sign here? Everybody, what is the sign? Negative. So it means that what? The direction is what? Negative. So the sign of R tells you the direction. So it's one thing you should be able to know. The other thing you need to know is this. R is between, the maximum R could go is -1. The lowest it could go, the highest it could go is 1. Is that okay? It means that you cannot get R to be 2 or 3. So in situations where you are getting R to be 2 or 3, know that there is something wrong, or anything greater than 1, or anything less than -1. Is that okay? So R is always between -1 and then 1. So one thing I would also say is that when we have our number line here, -1 is here, 1 is here. Okay? It means that 0 is in the middle here. Does that make sense? Okay. And then we know that R gives us the what? The direction and then the strength, isn't it? So whenever R is closer to 1, it means that it is very strongly positive. Is that okay? If R is closer to -1, it is strongly what? Negative. Is that okay? Does that make sense? So for example, if you have R to be 1, it is perfectly what? Positive. Is that okay? If you have R to be 0.9, it is strongly positive. It means the relationship between them is what? Strongly positive. If you have R to be -0.9, the relationship between them is strongly negative. Is that okay? But if you have R closer to here, it means that it is moderate or weak. Is that okay? So the more R gets to 0, then the strength reduces. Is that okay? Does that make sense? Any questions so far? Yeah, the R just tells the relationship, but the line of best fit, if the relationship is linear, it's just like a line that draws a good line between points. Yeah. One thing you should also know that correlation has no units. So for example, if I want to look at the relationship between the number of hours you spend studying for this course and your grades, even though your grades will be in percentages, doesn't have any units. Is that okay? And then you should also know that it is not affected by multiplying or shifting. We've already talked about multiplying data and then shifting. And then R only measures the relationship between what? Linear associations only. So for example, R is effective when we have something like this because this is what? Linear, a line. R is not effective in these situations. Does that make sense? So R is what? Effective in what? Only measures what? Linear associations. Is that okay? And then whenever you have an outlier, it affects R significantly. Does that make sense? Good. So the other thing I want you to do is that now that we have, so take your notes, form. What do we use to describe the form? Strength. What do we use to describe the strength? The direction. What do you use to describe the directions? We have those stuff. For example, strength, it could be strong, moderate, or weak. And then form could be straight, curved, and others. So try to write that. And then let's get to start Crunch and then load this data. Is that okay? When we load the data, we are going to construct certain scatter plots, and then we are going to comment on the form the strength, and then also the direction. So to get to StatCrunch, so I have StatCrunch here. Let's try to load the data. We go to data, load, share data set, and then SRA. Have you been able to load the data? Okay. So I would also encourage that whatever we do in class, try to do them on your screens too, because I realize that on your test, some of you assume that you know, but then when you are doing StatCrunch, you find some challenges. So try to learn how to do that here. And if you have any questions, you could ask, and then I'll be able to address that for you. So this graph here has X values and then various Ys. So let's try to play with some of them. So let's learn how to construct scatter plots. So to be able to do that, we go to graph, and then we go to scatter plot. So graph, we go to scatter plot, and then I click on that. And then let's choose the X variable to be X because it is X here. Let's choose the Y, let's do the Y variables one by one. So let's use this one first. If you want to let StatCrunch draw a line, like a line of best fit, you could change it to be 1. Is that okay? If you wanted to draw a line and then you click the line of best fit, is that okay? So if you want to draw a line, you could change here to be what? 1. And then you click best fit and it draws that for you. But I don't want to have a line now. So, and then we hit compute. And then we have this. So I want to ask everybody, what is the direction? I want to hear your voice. What is the direction? Positive, right? We all agree on that. Okay. Um, what is the form? What is the form? You all agree the form is straight. I want to hear everybody's voice. Is that okay? Feel free to talk. When you get it wrong, you learn well. Is that okay? So the form is what? Straight, right? Okay. Can you see outliers? No. You all agree cannot see outliers. Okay. What is the strength? You all agree it's strong. Okay. I don't want you to be just speak out. Is that okay? Good. So the strength is strong. Is that okay? Okay. Now let's go to a different one. Let's get to maybe this one. So this is what I did. I don't want to go over again. So I just click on, let me do. So I click on this one here, options, edit. Is that okay? Then I go to the Y variable here, and then I change the Y. Is that okay? That way I don't need to go do it again. Does that make sense? So, and I click on this one here, and then I hit compute. What is the direction? What is the direction? Okay, good. So now we get the direction right. What is the strength? It's positive, it's strong, but not too strong, but it's okay. But I won't give this moderate, I'll give it. So when you are doing your StatCrunch, I see it gives you strong positive, positive. So I'll say like this, we'll get to like the one you see like it's moderate, but This is a bit okay. What is the form? Good. And then can you see outliers? No. Okay. Let's get to the next one. Uh, what is the direction? So now we are agreeing that if anytime you see a scatter plot that is what linear, you should be able to get the direction right. Is that okay? Okay. So you agree that the direction is negative. Okay. What is the strength? Strong. Is that okay? So if you are commenting the relationship here is what? Strongly what? Negative. Does that make sense? Okay. What is the form? Straight. Right. Can you see outliers? Okay. What is the direction? Negative. Can you see that? Good. What is the strength? Weak. You said it's very easier for you to see, right? Weak. And then what is the form? Straight, right? Okay. Can you see outliers? I can see. They are just scattered apart. Is that okay? Let's get to another one. So you see, this is like a circle, right? Is that okay? So when there's a circle, what do we say? Right? Let's get to the last one. What is the form? Curved. Is that okay? Good. So now that you have this idea here, we want to be able to practice it on an example in the book. Is that okay? So go to As You Learn. There is a PDF there that I call it Scatter. It looks like this. Yeah. Do you all have this one here? It's on As You Learn. Oh, if I do that, I can see. So open As You Learn, but I think the pictures it's clear on the screen except the writing stuff might be difficult. So try to open that on your As You Learn. I'm trying to see if I could zoom in, but if I zoom in, I lose the four graphs. But it's okay. So let's see. The question is that which of the scatter plots below show little or no association? Anybody want to try? Mhm. The fourth one. What are you also saying? She also said four, right? Anybody else? I would say none. I wouldn't say fourth, though I agree with you from your point, but I'll say that it's weak, but you could say it's negative. Is that okay? Let's get to B. Negative association. 3 and 4. Is that okay? 3 and then what? 4. You agree? 3 is what? Strongly negative. Negative, weak. Is that okay? Does that make sense? Okay. But the question is what? Negative association. It doesn't matter whether it's strong or moderate or weak. The question is negative association. Does that make sense? The next one is that word. Linear association. Everybody, 2, 3, and 4. You agree? Linear means a line. Okay? A line here, line here, line here. Is that okay? So linear association is what? 2, 3, and then what? 4. Okay. A moderately strong association. A moderately strong association. What would you say? Moderately strong association. What are you going to say? 1 and 2. And why not 4? No, I see. So I would say 2, right? This is also like, this is strong. See, when it goes up. When it comes down, it comes down. Is that okay? But this is like curved. The collision coefficient will do very poorly on this because it's not good at what? Curves. Is that okay? A very strong association, what would you say? 3. A very strong, it doesn't matter, has to be positive. It could be negative or positive. The question is a very strong. If they say positive strong, then it's a different thing altogether. Does that make sense? A very strong could be positive or negative. The question is strong. Is that okay? If they say positive strong, it's a different thing. Positively, negatively strong, it's a different thing. Does that make sense? Okay. So looking at the same problems here, let's try to do same thing here. Which of the scatter plots below has little or no association? 1, right? Does that make sense? Okay. A negative association. 4. A linear association. 2, 3, 4. A moderately strong association. A moderately strong association. What would you say? I would say 3. The question is saying a moderately strong. I find this to be very strong. I find this to be very strong. I find this to be moderately strong. Does that make sense? Do you all agree with that? Right? Yeah. So sometimes the R is, I like the R because the R is, it's helpful because when you see 0.9, it's very strong. Right? Yeah. And then a very strong association, 2, 4. Right? Okay. You see this one, when you try to draw this, it's thin. It's also thin. Right? Let's get to question 7. I think we've done 7. Let's get to 11. So I'm going to show you tricks to answer problems like this. Is that okay? And I believe that they are going to make life easy. So here you have been given the scatter plots and you have been given the correlations. Is that okay? These are the correlations. Remember, I told you that when it's getting to the extreme, getting to +1 and -1, very strong. Does that make sense? Okay. So we have these ones here, okay? The question is that which is which, so you need to just what? Match them. Is that okay? One graph cannot have 2 correlations. Does that make sense? Okay, so I see here we have 4. We also have 4 graphs here. So it means that 1 to each of them. Is that okay? It's like 1-to-1 mapping. Okay. So this is what I would start. So I want you to tell me, which of these four graphs do you see positive direction? B. You all agree it's B. Okay. So remember, if it's positive direction, what should be the sign of R? Positive, right? Okay. So let's look at all these. What do you think should fit for B? 0.777. Is that okay? So we fixed that one. Are we all okay? Let's get to the next one. Which of these, so now we are left, we've taken B out. Which of these three left here has negative direction? C and D. Is that okay? Okay. C and D. Now that we've seen two, now let's rank them. Which of these is strongly negative? You agree with C. Okay. So now we know that if it's negative direction, the sign of R should be negative. Is that okay? So you see, we have these two here. Which of these two should go for C? Negative 0.923. Why? Because it's closer to what? Negative 1. Is that okay? So you see, we have fixed this one here. And since we have two, it means this also goes for what? This one. Is that okay? You've done this. You don't need to worry about it. The last one goes for this. I told you that for this ones, R is for linear. This is what curved. So R is always poor. Is that okay? Which means that this line here, you cannot model it using what? A straight line. You have to use a curve. That is a polynomial. We don't want to get to that stage now. Is that okay? Are we all good on this one? Okay. Let's get to 12. So 12, same thing. Which of these four graphs here, right, do we see a positive direction? BC. Do you agree? Okay, we have two. So BC, which of these two do you find it very strong? How many of you agreed C? Okay, good. So now we know that if it is positive, what is the sign of R? Positive, right? So let's get here. So it means that we are dealing with what? These two. Is that okay? So 0.736 should go for which one? B, right? 0.95 should go for which one? C. So you see we've answered that one. Is that okay? Now, which of these is what? The sign is negative. A. So you see this one is not really clear, but we've placed a post on that. We are doing the ones that is easier for us to identify. Is that okay? So A. And it's what? Strongly what? Negative. Is that okay? So that is what? Negative 0.977. What is left? Negative point. You see, this one is like there's no association because it's closer to zero. Is that okay? So that is for this one. Does that make sense? You have to be able to learn how to interpret these graphs. Does that make sense? StatCrunch computes this for you. It doesn't tell you directions, form. You have to be able to know that. When you compute the correlation coefficient, you should be able to tell it is strongly positive, strongly negative by using the sign and then the number. Is that okay? Do you guys have any questions so far? Okay. The other thing we want to do is to use StatCrunch to compute the correlation coefficient. So let's get to StatCrunch. So I want to compute the correlation coefficient for all these. Is that okay? So I go to Stats. I go to summary stats, and then I go to correlation, and then I click on that. So if you want just highlight those two, I want to do all of them. Is that okay? So I can highlight all of them. And then you hit compute. And it does that for you nicely. Is that okay? So you see, if we want to know the relation between X and Y, this number here is Y and Y. We don't want that. We want just X and Y. Is that okay? So let's focus on this one here. Does that make sense? So you see, for the first one, remember it was strongly positive. You see the correlation coefficient is like 0.95. Another one was okay, you see. And then the one that was curved, you see the R was what? 0. Is that okay? So the correlation coefficient always matches how the graph looks like. Is that okay? But that is a bit more accurate than maybe using our eyes to check. Is that okay? Any questions so far? So now you can use R to compute correlation coefficients. Is that okay? Good. You also have the formula over there, but R does that, so you can use R to do that. The other thing I want us to do is you can use StatCrunch to also play and guess the correlation coefficient. Let's try to do that. So once we are in StatCrunch here, let's get to applets. And then let's get to correlation by eye. I think this comes in your homework, so it's good to master your guessing. So applets correlation by eye. Is that okay? If you have a table, you could put in the table here and then you select and then you compute. Is that okay? But I don't have anything here. I want it to randomly generate for me. Is that okay? So I leave the random generated and I hit compute. Now, at your level, the sample data point is small. Okay, let me try to increase it to say 40. So we have more to guess. Does that make sense? And then I hit simulate. So when you look at this one here, what do you think should be the correlation coefficient? Can somebody guess? So I should put 0.1. Okay, let's see. Oh, it means that you guys, so it's like it allocates like plus or minus 0.1. Is that okay? So your guess is good. Let's try another one. What do you think it should be? So somebody say negative 0.73. One thing I would be furious if you get wrong is a sign. I would be very mad if you get the sign wrong. Is that okay? Because I expect you to get a negative right. Does that make sense? So negative 0.73. Let's see. Oh, I said try a weaker one. So this is too strong. Let's try 0.50 and see. Okay. Does that make sense? Let's try a different one. What do you think we should put here? I don't think 0.3 should be a good one. I think let's try maybe negative 0.6 or 0.7. A stronger one. Do we see that? So you can just be simulating and then be guessing. How about this one? Negative 0.9. I'll try maybe negative 0.95 because I see it's very strong, right? Negative 0.95. Oh, yeah, we got it. So that is how to play. I'll show you how to do that again. So we go to applets, okay? And then we go to correlation by eye. Click on that. This, I don't have any data. If you have data, you could put that here. But I don't have any data. I just want to play a game of guessing. I do randomly generated, I hit compute. And then try to, because when you keep playing, you can reduce the data sets to guess. But I think at your level, since you just started, you could do 40. That way you have more data points to simulate. Is that okay? Good. So that should be all for today. We'll continue the part 2 on Wednesday. Have a great day.